Factorizing, the magic practice that turns this expression into this more perfect thing. So today we'll be learning how to factorize expressions and polynomials. To make it easier, we will start from the beginning. How do we factorize any expression? Any simple expression, I mean. If we, for example, had 7 times 2 plus 3 times 2, we could write this down as 2 times 7 plus 3, because the product is distributive. And as a result, this is equal to this. The good thing here is that it happens the exact same thing when we have a variable, namely x. So to factorize any expression that contains an x, in a first instance we should factorize all the addends. This means that if we had, for example, 42 times x minus 14 times x squared, we should write each part of the addend as a product of prime numbers, and if there's an x or a y or any other variable, as a product of variables. This example would be equal to 7 times 3 times 2 times x minus 2 times 7 times x times x. If you don't know how to factorize a number, you should check the video where I explain it very easily. The second step to be followed is to see what factors are common in all the addends. In this case, it's easy to see that 7, 2 and x are common in both addends. So we will write them out of our parentheses. 7 times 2 times x. Now we open a parenthesis and we will write all the numbers we left behind. In this case, 3 minus x. Finally, we will multiply all the products that are out of our parentheses, giving us 14x times 3 minus x. And this would be the factorized expression. Check out that if we operate this, we get 14x times 3 minus 14x times x. That equals 42x minus 14x squared, the same expression we had at the start. Now, what happens if we have more than two addends? What happens if we have a second-grade polynomial? Well, in a first instance, we will have to check if our expression has a free term. We will have to see if there's a number without an x. If we have no free term, that would mean we would have an expression similar to the ones I showed you how to solve, and we will continue with the method I showed you. But if there's a free term, if there's a number with no x accompanying it, we will have to follow the next steps. First of all, we will have to use the quadratic formula to find what the roots of our polynomial are. Note that this is a method I want to show you and it's not the only one that exists, but usually it is the one that you can use to factorize any second-grade polynomial. So we will have to use the quadratic formula that you all know is minus b plus minus the square root of b squared minus 4 times a times c divided all by 2 times a. With the roots we get, operating this expression, we will have to rewrite those roots inside of a factor. Let's see it with an example. This is the expression I want to factorize. So I will use the quadratic formula, replacing the terms of our polynomial in the formula, and getting x equal to minus b, which is minus 3, plus minus the square root of b squared minus 3 squared minus 4 times a, which is 1, times c, which is minus 10. All of it inside of the radical and divided by 2 times a, which is 1. This expression equals to 3 plus minus the square root of 9 plus 40 divided by 2, which is equal to 3 plus minus the square root of 49 divided by 2 equal to 3 plus minus 7 divided by 2. And this gives us two solutions, two roots of our equation in case we wanted to solve it. Using the plus sign, we will get 10 divided by 2 equals to 5, and using the minus sign, we will get minus 4 divided by 2 equals to minus 2. Now, knowing these roots, we will have to write them inside of a parenthesis with an x, changing the sign of the root, so that x squared minus 3x minus 10 is equal to x minus our root 5 times x minus our root, which is minus 2. This is why I write it inside of a parenthesis. because we will have to change the sign of the root. So if we have a minus sign, once we multiply it by -1, we will get a plus sign. The point is that in this expression, its factorized form would be x minus 5 times x plus 2, which are the roots of our polynomial with the opposite sign. But take into account that in this expression, we had a 1 multiplying the quadratic addend. So if we had the x squared multiplied by any number, let's say a, we would have to multiply our expression times a. And now I'll show you why. Let's say we want to factorize this expression. We will use the quadratic formula to get the roots of our polynomial. So x would be equal to 3 plus minus the square root of minus 3 squared, which is equal to 9, minus 4 times a times c, divided all of it by 2 times 3, equal to 3 plus minus the square root of 9 plus 72 divided by 6, equal to 3 plus minus the square root of 81 divided by 6, equal to 3 plus minus 9 divided by 6. And this is equal to, using the plus sign, 12 divided by 6 equal to 2. And using the minus sign, minus 6 divided by 6 equal to minus 1. So some people may think that we would just have to write x minus 2 times x plus 1, which is what I told you to do if we had a 1 accompanying the x squared. But since we have a 3 accompanying the x squared term, if we operated this expression, we would get x squared plus x minus 2x minus 2. And this is equal to x squared minus x minus 2. And check that this is not equal to this, because this expression is 3 times this other expression. And they are not equal, even though their roots are the same. That's why using the quadratic formula has its risks. What would we have to do? Just multiply the expression we had times the number accompanying x squared. In this case, x minus 2 times x plus 1 times 3, which is the number accompanying x squared in our first expression. So, now that you know how to factorize a second-grade polynomial, we will start with the exercises. The first one of them is a polynomial without free term. So we will apply the first rules I told you. We will write all the addends as a product of prime numbers and as a product of variables, getting this over here and 3 times 2 times x. Now we will take only the common ones, which are 2 and x, since 3 is not in the first addend, and write them out of the parentheses. Now we will write the rest of the products, conserving our sum, and this would be the solution. Second one, as you can see, both of the addends have 1x, so we can just add them, taking as result 9x. But we could also have applied the first method, writing all the addends as a product of prime numbers and variables, getting 3 times x plus 2 times 3 times x, writing the common ones, and now the rest of the products. As you can see here, we don't have more products, so we will write a number 1. And in the other place we had a 2. The expression inside of the parentheses is a composition of numbers, of real numbers, so we can add them, getting 3x times 3. This is a product we know how to operate, equal to 3 times 3 times x, equal to 9x. But it's way easier to do the first thing I showed you, as well as the most intuitive way. Number 3, we don't have a free term, so we will write all the addends as a product of things. 2 times 2 times 2 times 2 times x times x times x minus x times x. This equals 2, take the common ones, x times x, open parentheses, and now write the rest. 2 times 2 times 2 times 2 times x minus, here we have a 1. This equals to x squared times 16x minus 1. And this is our solution. The next one, we already have one factor out of the parentheses. This means we don't have to touch it. We will keep it as it is. X times, and now we will factorize the internal part of the parentheses. 3 times x minus 3 times 3 times x. Close parentheses equals to x times we take the common ones, 3 times x, we open again another parenthesis, and we write x minus 3, close parenthesis, close the first parenthesis, and this is equal to, we can multiply these terms over here because we have only a product. We don't have an addition or subtraction, and we will get 3 times x squared times x minus 3, which is our solution. The next expression may be known by some of you. It is a notable product, and in this case is written x plus 1 squared. However, we can apply the method I showed you. We can use the quadratic formula to get the roots and then factorize the expression. So that's what we will do. Let's replace in our formula x is equal to minus b, in this case b is 2, so minus 2 plus minus square root of b squared, 2 squared, minus 4 times a, which is 1, times c, which is 1 also, divided by 2 times a. As we know, a equals 1, so we will write divided by 2. This is equal to minus 2 plus minus the square root of 4 minus 4 divided by 2, equal to minus 2 plus minus 0 divided by 2, giving us two solutions. If we use the plus sign, we will get minus 2 divided by 2, which equals minus 1. If we use the minus sign, we will get minus 2 divided by 2 equals minus 1, getting a double root, and as a result, having two solutions. Therefore, we will have to write x minus our solution, minus 1, times x minus our solution, minus 1. This is equal to x plus 1 times x plus 1. And this is equal to x plus 1 squared, the same result I showed you at the start. So that would be our solution. Let's get to the next one. Paragraph F. We have an expression with free term, with a constant term. So we will have to use the quadratic formula and then multiply it times the term that accompanies x squared. So x is equal to minus b minus 5 plus minus the square root of minus 5 squared minus 4 times a times c. All of it divided by 2 times a, which is 3. So 2 times 3. This is equal to 5 plus minus the square root of 25 plus 24 divided by 6 equal to 5 plus minus the square root of 49 divided by 6 equal to 5 plus minus 7 divided by 6, which gives us two solutions. The first one, 12 divided by 6 equals to 2, and the second one, minus 2 divided by 6 equals to minus 1/3. So with these two solutions, these two roots, we can write almost our expression factorized, and we would write x minus our root 2 times x minus our other root, minus 1/3. Now we will have to multiply times the term that accompanies x squared. So we multiply times 3. Now we will have to finish simplifying our expression, getting x minus 2 times x plus 1/3 times 3. And some people prefer writing the 3 at the very start, so do what you want and what your teacher asks you. This would be our solution. Let's go with the last one. We can see there is no free term. All the terms are accompanied by an x. So we will have to do the first method I showed you. We will write all the addends as a product of factors, getting x times x times x plus 5 times x times x plus 2 times 3 times x. We see that there is only an x in common in all the addends, and we will write x times the rest of the factors, x squared plus 5x plus 6. Now, we have an expression inside of the parentheses that is a polynomial, a second-grade polynomial. So we will keep factorizing it as if it wasn't being multiplied by x. We will get the roots with the quadratic formula. X is equal to minus 5 plus minus the square root of 5 squared minus 4 times 1 times c, which is equal to 6, divided by 2 times a. equal to minus 5 plus minus square root of 25 minus 24 divided by 2 equal to minus 5 plus minus 1 divided by 2, giving us two solutions that are minus 3 and minus 2. Now, our factor would look like the x we had at the very start times our inside expression factorized, x minus the first root times x minus the second root. And now it has to be multiplied by the term accompanying x squared, which in this case is only 1. So we multiply by 1 and it changes nothing. Now we operate this and we get x times x plus 3 times x plus 2. And now we have our expression factorized correctly. I hope you guys understood how to factorize products. If you need anything else, just check my channel. I'm sure you will find what you want, and I'm just going to try to draw a pyramid over here while the video ends. So have a nice weekend.